Imagine you're in a room full of people, trying to guess someone's favorite ice cream flavor based on a single clue. What if I told you that naive Bayes, a simple yet incredibly powerful machine learning algorithm, works in a way that's completely different from what you might expect? Most people think it's just a mathematical formula for probabilities. But there's something fascinating about how it actually predicts outcomes. In this video, we're going straight to the heart of naive Bayes. We'll dive into the code to show you how to import data, pre-process it, visualize it, and build a model that works like magic. But before we dive into the code, make sure to subscribe so you don't miss any of these practical hands-on ML guides. Here, we're importing the essential libraries for our project. Pandas and NumPy will help us handle and process the data, while Matplotlib and Seaborn will let us create clear and insightful visualizations. We're loading the dataset, previewing the first few rows, and checking its size to understand the data structure. We're creating a line plot to compare maximum and minimum temperatures over time. This helps us identify any trends or variations in the dataset, making the patterns clearer. We're calculating the average precipitation for each weather type and visualizing it with a bar chart. This gives us a clear idea of how precipitation varies across different weather conditions. We're using a scatter plot to show the relationship between maximum temperature and wind speed. We're creating a histogram to observe the distribution of precipitation levels in the dataset. We're using a box plot to compare the distribution of maximum temperatures across different weather types. We're generating a heat map to visualize the correlations between numerical features like precipitation, temperature, and wind, highlighting their relationships. We're using a pie chart to visualize the distribution of weather types in the dataset. This helps us see the proportion of each weather condition and how common they are. We're dropping the date column as it's not needed for the analysis. We're applying Label Encoder to transform the weather column into numerical values, as machine learning models work better with numerical data instead of text labels. We're splitting the data into features, X, and the target variable, Y. We're splitting the data into training and testing sets, using 80% for training and 20% for testing. We're initializing a naive Bayes model and training it on the training data. This allows the model to learn the relationship between the features and the target variable. We're making predictions on the test data using the trained model. We're evaluating the model's performance by calculating accuracy, generating a confusion matrix, and providing a detailed classification report. We're printing the model's accuracy, confusion matrix, and classification report to assess how well it performed on the test data. Now that we've built and evaluated a naive Bayes model, but we're just getting started. In the next video, we'll dive into gradient boosting, an even more powerful technique that can take your models to the next level. Stay tuned, and don't forget to subscribe so you don't miss it.